Hello everyone, I'm Nandita. Today I am here to present before you one of my research work, a novel multiband polarization insensitive metamaterial absorber, and I am affiliated to research facility in Applied Electromagnetics, Department of Physics, Government Victoria College, Palakkad, India, and co-authored by Dr. Gobi Krishna. Metamaterials. The name metamaterial is a combination of two words, meta and materials, where the name meta means it's a Greek word meaning beyond. They are artificially engineered structures in which extraordinary electromagnetic properties are obtained that is not found in the naturally occurring ones. Metamaterials are also known as double negative media because they have permittivity as well as permeability negative for the same frequency range. The negative permittivity and negative permeability is obtained by the combination of two structures, the periodic arrangement of thin metallic wires as well as the split ring resonators can produce double negative media, and they are also known as negative index materials. These are applications of metamaterials in three different frequencies: microwave frequency, terahertz frequency, as well as optical frequency. We mainly focus on radar absorbing material. Electromagnetic absorbers. As the name indicates, they are the structures that are able to absorb incident electromagnetic wave. An ideal wave absorber is able to absorb all incident electromagnetic waves regardless of the incident wave direction, polarization, and frequency. However, an ideal electromagnetic wave absorber does not exist. The figure shows one of the electromagnetic absorbers known as resonant absorbers, in which the resonance mainly depends upon the frequency. In these type of absorbers, we can make absorption in one or more discrete frequencies. Now, my work, a novel multiband polarization insensitive metamaterial absorber. The final design is obtained by the combination of two individual structures. One is cross resonator and the another one is split ring resonators. We first individually simulated the two structures, and the cross resonator shows absorption at 2 bands and the split ring resonator shows absorption in 3 bands. By the combination of these two structures, we obtain the final design which shows absorption at 5 resonant frequencies. This is the unit cell design of the proposed metamaterial absorber. And our structure shows 5 resonant frequency. Our proposed design shows absorption at 5 resonant frequencies starting from 1.57 GHz, 3.7 GHz, 5.6, 7.2, and 9.24 GHz. And we also check the polarization insensitivity nature of our structure by varying the polarization angles from 60 to 360 degree, and the absorption remains constant at various polarization angles. In order to study the absorption mechanisms that occur in this structure, we mainly study the surface current distribution as well as the electric field distribution. The figure shows a surface current distribution at 5 resonant frequency, and we can observe that there are anti-circulating currents in the top and bottom metallic planes, and these two anti-circulating currents behaves like a magnetic dipole which can produce a magnetic field that interact with the incident magnetic field and cause a magnetic resonance at 5 different frequencies. This figure shows the electric field distribution at the top metallic plane. Due to the incident electric field, charge separation occurs mainly on the top metallic plane, and the red color shows the high charge density and the blue color shows the low charge density. Due to this charge separation, they behaves like an electric dipole and can couples with the incident electric field and cause the electric resonance at 5 different frequencies. This is the PCB layout of the proposed structure, and the next figure shows the experimental setup in our lab. These are the results that is compared between the measured and simulated results. The first figure shows the return loss from the measurement as well as the simulation, and the next figure shows the absorption results. Equivalent circuit analysis. We designed an equivalent circuit in order to study the electrical behavior of the proposed absorber. So the first 5 LCR circuit acts as a resonator for the 5 resonant frequency, and the 6th LCR acts as a resonator for the solid copper ground. In order to isolate the 5 resonant frequency, we use the capacitors from C7 to C11. These are the results compared from the ADS circuit simulation as well as the CST simulation, and they found to be similar at 5 resonant frequencies. This is the comparison of our work with the earlier ones. The proposed design shows absorption starting from the lowest frequency 1.57 gigahertz, 3.7, 5.6, 7.2, and 9.24 gigahertz, and the structure shows a near unity absorption at 5 different frequencies. So now let me conclude my session. In this study, a multi-band polarization insensitive metamaterial absorber has been proposed. The structure exhibits a perfect absorption at 5 different frequencies, and the fourfold symmetric nature of the proposed unit cell provides the polarization insensitivity behavior of the structure. In order to study the absorption mechanism of the designed absorber, we mainly focused our study on surface current distribution as well as the electric field distribution. The experimental results indicates a close correspondence with the simulation. The near perfect absorption and the polarization insensitivity of the present absorber makes it a good candidate in variety of applications such as electromagnetic filters, sensing, and steel technology. These are my references. Thank you.